Okay friends, so we move on to the last part. Okay, and that is made up of three molecules. Which are those? Boron, carbon and nitrogen. Okay, now I already told you that I am going to explain this three molecules of boron, carbon as well as nitrogen in a way that you first of all try to understand boron and then you can understand the carbon as well as the nitrogen very easily. Now in this case, there is some assumptions which has to be taken into consideration so that the theoretical approach matches with the experimental approach. Okay, so how it is, I'll explain you. So we start first of all with the boron molecule. And when you talk about a boron molecule, its formula is B2. The 6 points are going to be same. The first point is, yes, you know it very well now, electronic configuration of the combining atoms. And that is going to be boron, atomic number of which is 5. We are only going to consider the valence shell electronic configuration, so it is 2s2 into p1. So that means we have 3 electrons per boron, so we have to arrange 6 total. 3 per boron, so 2 boron, 6. Next is, we go into overlapping of atomic orbitals. Okay, you know all these things now very well. So, the 2s orbital of both beryllium atoms overlap, resulting in the formation of 2 molecular orbitals, sigma 2s, sigma star 2s. Next is we have 2 pz orbitals. So 2 pz orbital of both boron, I'm sorry, it's not beryllium, it's boron, of both boron atoms overlap. It will also result in 2 molecular orbitals, which are those sigma 2pz and sigma star 2pz. Z is a bonding axis, so it will result in sigma bonding. And then the last one we talk about is 2px and 2py of both boron overlap, and that will result in 4 molecular orbitals, and that will be pi 2px, pi 2py, pi star 2px and pi star 2py. Okay, this is the way the orbital are being formed, bonding as well as antibonding. We are now going to the next point, that is point number 3. Distribution of electrons in the molecular orbital. Now here there is some assumption which I was talking about, and that is, when you talk about the assumption part, how exactly that assumption is. We are assuming that the 2s and the 2pz, okay, those 2 orbitals which are involved in sigma bonding, because the energy level is less, difference is less, and therefore they will combine with each other. Once again I repeat, the assumption that is being taken into consideration for these set of molecules, boron, carbon and nitrogen, is that is the 2s and the 2pz orbital, okay, both of which results in sigma bonding. They got a lesser energy difference and hence they will overlap with each other. In the terms of valence bond theory, we use the word hybridization. Okay, we use the word hybridization. So because of this, what is going to happen? Due to this mixing of orbitals of 2s and 2pz, what is going to happen is the sigma 2s orbital energy is lowered. This I am talking about in comparison to what? Yes, the previous 3 molecules which I have explained to you. Which were those molecules? Oxygen, fluorine and neon. Alright? So, what happens is, the 2s energy level is lowered and the 2pz energy level, sigma 2pz energy level is raised. Because we talk about hybridization, we talk about stability. So, stability is related to strength and strength is related to sigma bonding. So we don't consider pi bondings over here for hybridization. So pi to px और pi to py के बारे में कोई जिक्र नहीं करना है. हमें सिर्फ सिग्मा 2s और सिग्मा 2pz के बारे में बोलना। ऑल्सो स्टार के बारे में भी नहीं बोलना, बिकॉज दोस आर एंटी बॉन्डिंग, दे आर अनस्टेबल। ओके, सो हाइब्रिडाइजेशन इज नॉट अकाउंटेबल फॉर द अनस्टेबिलिटी पार्ट। ओके, सो वो सब अनहाइब्रिडाइज्ड में है। सो ओनली स्टेबिलिटी की जब हम बात करेंगे तो वी आर ओनली गोइंग टू फोकस ऑन सिग्मा 2s एंड सिग्मा 2pz, बस सिर्फ ये दो। So due to the mixing of the 2s and the 2pz orbitals, the sigma 2s molecular orbital, the energy is lower and sigma 2pz energy level is raised. Okay? तो इसके वजह से क्या हो जाएगा कि sigma 2pz का energy level become higher than the pi 2px and pi 2py. Alright? I'll explain you this by the help of a diagram so that you can recollect. I will show you side by side two diagrams. First about O2, F2, Ne2. This is about B2, C2 and N2. So sigma 2s next is we have sigma star 2s, then sigma 2pz, then we had pi 2px and pi 2py, then I told you pi star 2px and pi star 2py, and then sigma star 2pz. Okay, this was already been discussed. Now what happens is sigma 2s energy level is slightly lower. Okay, sigma star 2s. Now see what happens is sigma 2pz energy level is raised because of the mixing of the 2s and the 2pz orbital. So as a result of which what happens is nothing happens to this. Please be very clear. Okay, it is same. The pi 2px and pi 2py, no change in the energy levels. Okay, this also pi star 2px and pi star 2py, we'll keep it as it is. Sigma star 2pz also we keep it as it is. Only thing what is happening now is, and that is that pi 2px and pi 2py, the energy level is same. Now the sigma 2pz energy level is raised. So when the energy level is raised, so it will come somewhere over here. Okay, so this will be now sigma star 2pz. I'm sorry, sigma 2pz. Okay, इसका सिग्मा 2pz का एनर्जी लेवल रेज हुआ तो ये इसके ऊपर चला जाएगा, तो ये ऐसे हो जाएगा। तो सिग्मा 2pz नाउ विल बी अबव पाई 2px एंड पाई 2py। एंटी बॉन्डिंग में कोई चेंज नहीं है। ओके, इन द एनर्जी लेवल्स। ओके, तो वापस से बोल देता हूँ, अभी एनर्जी लेवल्स में क्या चेंजेस है। सिग्मा 2s सिग्मा स्टार 2s एज इट इज, एक ही चेंज है, दैट इज पाई 2px पाई 2py इमीडिएटली विल बी कमिंग आफ्टर सिग्मा स्टार 2s, और पाई 2px एंड पाई 2py के ऊपर क्या आएगा, सिग्मा 2pz। ओके, दैट इज द ओनली चेंज। यानी आप देख सकते हो, अगर लेवल के हिसाब से अगर आप देखना चाहोगे तो इन सिंपल वर्ड्स आई विल से यू जस्ट हैव टू फ्लिप दिस टू। ओके, ये और ये आपको फ्लिप करना है। ओके, सिग्मा 2pz ऊपर जाएगा, पाई 2px पाई 2py नीचे आएगा। एक्चुअली इन ट्रू सेंस देयर इज नो चेंज एट ऑल इन द एनर्जी ऑफ पाई 2px एंड पाई 2py। प्लीज बी वेरी क्लियर, बिकॉज इट इज नॉट इन्वॉल्व इन हाइब्रिडाइजेशन। ओके, सिर्फ ये ऐसा ही है, पाई 2px एंड पाई 2py, और पहले सिग्मा 2pz ऐसा नीचे था। अभी ड्यू टू द मिक्सिंग द सिग्मा 2pz कम्स अप, दिस विल रिमेन एज इट इज। ओके, दैट इज द ओनली चेंज व्हिच हैज टेकन प्लेस, so that the approach can be as per the experimental approach of the magnetic properties of boron as well as carbon. Okay, so that's why we are assuming mixing of the sigma 2s and sigma 2pz orbitals, and because of that sigma 2s energy level is raised, sigma 2pz energy level, sigma 2s energy is lower and sigma 2pz energy level is raised, and it goes above the pi 2px and pi 2py. So this is what is the order of energy. So now I'll start filling up of electrons. How many electrons I need to fill up is 6. So first 2 electrons goes in sigma 2s, the second 2 electron goes in sigma star 2s. Now the 5th electron will go in pi 2px, the 6th electron will go in pi 2py. You know this why? Yes, it's because of Hund's rule. तो क्या बोलना है यहाँ पे? 2 electrons occupy sigma 2s and sigma star 2s. 1 electron occupy pi to px and pi to py. तो अभी कितना इलेक्ट्रॉन हो गया देखो, 2 इलेक्ट्रॉन इधर हो गया, 4 और 2 6. So I have to arrange 6 electrons. So 2 2 4 single, so that means 6 electrons. Okay, so this is about the distribution of electrons in the molecular orbital. I hope you have understood the changes which are there. In simple words, just one change, okay, in terms of the energy level, and that is to pz, sigma to pz is above, pi to px and pi to py is below. Okay, that is the only change. That's it. Otherwise, everything is same. And I have also given you the reason why it is. It is because of the mixing of the orbitals, so that it is as part of the experimental observation about paramagnetism and diamagnetism. ठीक है, अगर मैंने 6 इलेक्ट्रॉन्स इधर अरेंज किया होता तो 2 इलेक्ट्रॉन्स over here, 2 electrons over here, 2 electrons over here. So that means all the electrons are paired, and therefore we say that the boron molecule is diamagnetic. But experimentally it is proved that it is paramagnetic. और वो paramagnetic कभी होगा, इस तरीके से होगा. समझ में है? तो एक्सपेरिमेंटल ऑब्जर्वेशंस को ओके उसके साथ अब मैच करना है, उसको एग्रीमेंट करना है, इसलिए हम लोग ने ये एजम्पशन किया अबाउट मिक्सिंग ऑफ ऑर्बिटल्स, ताकि यहाँ पे 2 सिंगल इलेक्ट्रॉन आ जाते एंड देयरफॉर बोरॉन मॉलिक्यूल इज पैरामैग्नेटिक. अंडरस्टूड दिस? So this was about, my dear friends, point number 3. We go into point number 4, electronic configuration of the molecule. So it's very simple. I've already told you, from lower type to the higher. This is all with respect to energy. याद रखिएगा ये. So from lower to higher, वो सारे orbitals लिख डालो जिसमें electrons है. तो sigma 2s2, sigma star 2s2, pi to px1 and pi to py1. That's it. Done. Okay, ये electronic configuration of the molecule. Bond order, you know the formula, half into number of electrons in bonding. कितने हैं without star वाले? 2 3 4 minus anti bonding में कितने हैं? 2. Okay, तो 4 minus 2 is 2 and half into 2 is 1. So that means there is a single bond between the 2 boron atoms. And the last part, the most important, is the magnetic property. That is the reason we have to bring about some changes into this. Okay, and the magnetic property is 2 single electrons are present, one in pi to px and the other in pi to py, and therefore it is going to be what? Paramagnetic. Okay, therefore it is what? Paramagnetic. So these are point number 6, that is magnetic property. So I hope you have understood the difference, the change. Only one simple change is to explain, to make the agreement of the theoretical approach with that of the experimental approach with respect to the magnetic properties. It is assumed that the 2s and the 2pz orbitals mix with each other because they are along the axis. They result in the formation of sigma bonding. In terms of valence bond theory, we use the word hybridization. Hybridization is always related towards stability. So therefore we don't consider the pi orbitals and nor we consider the antibonding orbitals. So due to the mixing of the 2s and the 2pz orbitals, what is the conclusion? The sigma 2s is lower and sigma 2pz energy is raised. Okay, and that means sigma 2pz is above the pi to px and pi to py. Okay, that is the only change. Otherwise, everything remains the same. So please, my dear friends, have a look at the 6 points of boron molecule. And once you understand that, then I guess carbon and nitrogen is very easy. In few seconds, it will get over. So please, देख लीजिए आप लोग ये. Okay, done. So we go into the next one. Is carbon. This is a C2 molecule. Atomic number, you know it, is 6. So this will become 2s2 and 2p2. 4 electrons, carbon tetravalent, everybody knows this. So 4 is a number which is associated with carbon. Overlapping of atomic orbitals, everything remains the same. Only thing is, instead of B, we have to replace it by C. That is carbon. Okay? B is replaced by C. Distribution of electrons, yes. How many electrons I need to arrange? 4 electrons per carbon. So for 2 carbon there will be 8 electrons. यानी 2 इलेक्ट्रॉन मुझे ऐड करना है, तो कहाँ पर करूँगा? ये देखो आपने सिंगल सिंगल दिख रहा है, तो उधर ही मुझे ऐड कर देना पड़ेगा ऐसे. It won't go into sigma 2pz, alright? Because sigma 2pz में electron तभी जाएगा when the lower energy level is completely filled. So 2 electrons occupy sigma 2s, sigma star 2s, okay, and then I need to remove this, okay, and it will be pi to px and pi to py. Pi to px, pi to py. This is the way it has to be. Electronic configuration of the molecule, very simple. I need to make it as pi to px 2 and pi to py 2. So total number of electrons आप देख लीजिए, 2 and 2 4, 2 6, 2 8, 4 and 4. That means 8 electrons. Now those 2 electrons, okay, where are they being added? Of course, they are being added into the bonding molecular orbital. So now it will become 6. देखिए आप without star देख लीजिए, 2 and 2, 4 and 2, 6. 6 minus 2 is 4, divided by 2 is 2. So that means we say that there is going to be what? A double bond. Okay, between the 2 carbon atoms. Okay, double bond between the 2 carbon atoms. Now magnetic property, all the electrons are paired. All electrons are paired, and therefore it is going to be what? Diamagnetic. Alright, so you can see now, within few minutes we have finished up with the carbon molecule. If you have understood the boron molecule, carbon molecule is as simple as that. Only minor changes we have done in the electronic configuration and in the magnetic properties. Okay, if मैंने 8 इलेक्ट्रॉन्स यहाँ पर अरेंज किया होता तो क्या होता? 2 इलेक्ट्रॉन इधर, 2 इलेक्ट्रॉन इधर 4, 2 इलेक्ट्रॉन इधर 6 एंड हंस रूल 7 and 8. तो क्या हो जाता वो? पैरामैग्नेटिक. Okay, C2 molecule would have become what? Paramagnetic if I had gone for this. But experiment has suggested that C2 molecule is not paramagnetic, it is diamagnetic. Understood? तो ये experimental observations के agreement में लाने के लिए we have considered this. Okay, now I think everything is absolutely crystal clear for all of you. So please have a look at the carbon molecule now. Okay, so once carbon is clear, we go into the next one, the last molecule now, and that is nitrogen molecule. Nitrogen means it is N2 molecule. Now when you talk about nitrogen, its atomic number is 7. So we have 2s2 and 2p3. Instead of 4 electrons, we will be having what? 5 electrons. Now the C is replaced by N. Alright? Now, what about the distribution of electrons? How it's to be considered is, total I need to arrange how many electrons? 10. 5 plus 5 is 10. So now the 2 electrons will go in where? Sigma 2pz. Okay, sigma 2pz में 2 electrons जाएंगे. So 2 electrons will occupy pi to px and pi to py are completely full. So that means the next 2 electrons will go into sigma 2pz. And therefore in electronic configuration I need to add sigma 2pz 2. So 2 electrons are getting added where? Into the bonding molecular orbital. तो ये हो जाएगा अभी 8. Without star it will become 8. See this? 2, 4, 6 and 2, that is 8. So half into 8 minus of 2, that is equal to 2. So therefore, 8 minus of 2 is 6 divided by 2 and that is 3. And therefore we say it's going to be a triple bond between the 2 nitrogen atoms. Okay? Since the electrons are getting added up in the bonding molecular orbital, so the bond order increases by 1. ये याद रखिएगा. ओके जैसे हम जाएंगे कहाँ से कहाँ, बोरॉन से कार्बन से नाइट्रोजन। जो मैंने इससे पहले वाला पार्ट पढ़ाया था, ऑक्सीजन टू फ्लोरीन टू नियोन, उसमें क्या हुआ था, 2 electrons were getting added into the anti-bonding molecular orbit and therefore the bond order was reducing by 1. यहाँ पे the bond order is increasing by 1. Okay, B2 में bond order was 1, C2 में it was 2 and N2 में it was 3. You understand this? Okay, ये याद रखिएगा। O2 molecule में it was 2. ओके फिर जब हम F2 में गए तो एक कम हो गया तो वो 1 हो गया, और फिर हम Ne2 में गए तो एक और कम हो गया, 0 हो गया, और फिर मैंने आपको बोला था the molecule does not exist. Okay, so this is what the comparison you can make it, okay, between these two sets of molecules. Magnetic property, all the electrons are paired and therefore it is going to be what, diamagnetic. So that's it with respect to boron. Okay, the minor changes, and we have done with carbon as well as nitrogen also. Okay, so please have a look at it, at the nitrogen molecule, everyone. Alright, so this was about the 6 points of explanation with respect to boron, carbon and nitrogen, and now the 7th and the most important point, and that is I will be showing you the molecular orbital diagram. उसमें भी मैं वही तरह से दिखाऊंगा कि पहले बोरॉन का मॉलिक्यूलर ऑर्बिटल डायग्राम दिखाऊंगा और उसके बेसिस पे आई विल एक्सप्लेन यू अबाउट द कार्बन एंड द नाइट्रोजन एज वेल. ओके, सो वी नाउ गोइंग टू द मॉलिक्यूलर ऑर्बिटल डायग्राम ऑफ B2, C2 एंड N2. सबसे पहले मैं आपको मॉलिक्यूलर ऑर्बिटल डायग्राम बोरॉन का बताऊंगा और फिर माइनर चेंजेस, याद है ना आपको? यस, माइनर चेंजेस से कार्बन और नाइट्रोजन भी आपको समझ में आ जाएगा. सो वी स्टार्ट विथ, this is with respect to energy. Okay, you know the layout very well. Atomic orbital, we are talking about B2 molecule, so atomic orbital of boron on one side, atomic orbital of boron on other side, and the molecular orbital of B2. Okay, now one is on the same straight line, one is, and here what I'll say is non-bonding. Okay, we now start with 2s. So on the same straight line, the 2s orbital of the another boron, these two overlap, resulting in one that is bonded and the other will be anti-bonding. This is sigma 2s, this will be sigma star 2s. Now the 2p orbitals of one boron, same energy, 2p orbitals of another boron. दो लेवल्स है दोस्तों, एक बॉन्ड 2pz का, मतलब एक सिग्मा का और एक पाई का. So 2 levels for bonding and 2 levels for anti-bonding. Okay, now you know the difference, yes? Yeah, right? Okay, तो यहाँ पे क्या आएगा, pi to px and pi to py, flip करना याद है ना, and this will be sigma to pz. No change as far as the anti-bonding is concerned, so it will be pi star to px, pi star to py, and this will be sigma star to pz. No change in the levels. So this is, my dear friends, the structure of the molecular orbital diagram of boron molecule. Now we start arranging the electrons, और यही structure रहेगा for carbon as well as nitrogen also. Okay, so we begin with 1s2, 1s2, 2s2, 2s2, और यहाँ पे है 2p1. So it is 2p1. Left plus right is equal to center. So 2 plus 2 is 4, so 2 electrons at the bottom, 2 electrons at the top. कोई change नहीं है यहाँ. Okay, is simple. अभी यहाँ पे जाइए. Left plus right, 1 plus 1 is 2. तो center पे 2 होगा. We have to start with pi to px. Hund's rule you know very well. So your two electrons will be in pi to p xn, pi to p y, single electron, and therefore B2 molecule is paramagnetic, which is in agreement with the experimental observations. Alright, so please देख लीजिए एक बार boron molecule का molecular orbital diagram, and then within seconds I'll explain you carbon and nitrogen also. Alright, done. So we go into the next molecule, and that is C2 molecule. So B is replaced by C. Alright, so it will be 2s2 and 2p2. तो यहाँ पे इलेक्ट्रॉन आएगा, यहाँ पर एक इलेक्ट्रॉन आएगा. These two added electrons will go over here. So pi to px में pairing and pi to py में there will be pairing. Okay, so this you can get it the molecular orbital diagram of carbon. See how it is easy. Boron समझ में आया, carbon is so very easy. Okay, just few seconds, that's it. So please have a look at it. Alright, so now the final part under this is N2, nitrogen molecule, atomic orbital of nitrogen. यहाँ पे we are going to talk about the molecular orbital part. ठीक है, 1s2, 2s2 and 2p3, so one electron has to be added over here. One electron has to be added over here, so total 2 electrons to be added. कहाँ जाएगा? Obviously, it will go in sigma to pz. Okay, उसमें 2 electrons आएगा, and that is it. Okay, you can keep a timer also. You will understand how quickly we get the molecular orbital diagrams. Okay, so if boron is clear, then carbon and nitrogen also gets cleared. Alright, so please have a look at it. So that's it, my dear friends. In this video, as I told you, I wanted to discuss with you all the applications of the molecular orbital theory to the homonuclear diatomic molecules. Okay, शुरुआत में अगर आपको याद है मैंने बोला था 10 molecules की पढ़ाई करनी है. कितने? 10 molecules की. लेकिन once the entire part is clear, okay, I'm very sure we have come to the conclusion that we have to actually learn only 3 molecules: hydrogen, बोरॉन एंड ऑक्सीजन. ये 3 मॉलिक्यूल्स का पढ़ाई किया, बाकी का 7 मॉलिक्यूल्स यू कैन गेट इट वेरी फास्ट. लाइव डेमोन्स्ट्रेशन करके दिया मैंने आप लोगों को. इफ यू अंडरस्टैंड हाइड्रोजन, हीलियम, लिथियम एंड बेरिलियम, डन. इफ यू अंडरस्टैंड बोरॉन, कार्बन एंड नाइट्रोजन इज डन. एंड इफ यू अंडरस्टैंड ऑक्सीजन, फ्लोरीन एंड नियॉन इज डन. Okay, so that's it. Okay, so this is the way you need to learn these molecules on the basis of molecular orbital theory. I am very confident that everyone has very clearly understood the entire part. Okay, so thank you so much for watching this particular video, and I please request all of you, okay, for the upcoming videos, please subscribe this my channel so that you get the notification very easily and very fast. Thank you so much.